All right, so protactium 23,4M, a toxic radioactive metal with no known use, has a half-life of 1.17 minutes. How long does it take for a 10 milligram sample to decay to 2 milligrams? So we have y equals AB to the x. Well, we want it to decay to 2. It starts out at 10. The decay value is 1/2. My x, if you remember, is x over my rate, which is 1.17. Okay, so now we just solve. Divide each side by 10. So we're going to get 0.2 equals 1/2 to the x over 1.17 power. Let's log both sides. So I'm going to get log of 0.2 equals x over 1.17 times the log of 1/2, which is 0.5. Divide each side by 0.5. So I got, or the log of 0.5, I should say. So the log of 0.2 over the log of 0.5 equals x over 1.17. So multiply each side by 1.17 to get it over. So 1.17 times the log of 0.2 over the log of 0.5 equals x. Now that's calculator work we can easily do. So that's 1.17 times the log of 0.2 divided by the log of 0.5. Okay. Log of 0.2 divided by the log of 0.5 times 1.17. 2.71. So x equals 2.71 minutes. (52) A town gets smaller. The population of its high school decreases by 12% each year. The student body numbers 125 right now, and how many years will it number 75? So y equals AB to the x. So 75 is what we're going to end up with. Our A value is 125. My rate of decay is going to be, my B value is going to be 1 minus 0.12, which will be 0.88 to the x. So divide each side by 125. So 75 divided by 125.6. So it's going to be 0.6 equals 0.88 to the x power. So I'm going to log both sides. So I get the log of 0.6 equals the log of 0.88 to the x power. We can drop the x with the power property, so the log of 0.6 equals x times the log of 0.88. Divide each side by the log of 0.88, so I get the log of 0.6 over the log of 0.88 equals x. So I got the log of 0.6 divided by the log of 0.88. 3.99. So x equals 3.99. So you could say 4 years. Okay, next example. Determine the growth factors for Florida and New York. Then write an equation to model each population's growth. All right. So Florida's population is growth is 2.13%. So the rate of growth would be 0.0213. Okay, so my B value for Florida would be 1.0213. Okay, for New York, the growth is 0.54%, which would be 0.0054. So the B value for New York would be 1.0054. Okay, so the equation for Florida would be y equals 15,982,378 times 1.0213 to the x power. All right, for New York, y would equal 18,976,457 times 1.0054 to the x power. So that's A. B, estimate when Florida's population might exceed New York's population. So for that to happen, they first have to become equal. So we can just set them equal to each other. 15,982,378 times 1.0213 to the x equals okay, I'm just writing all this out. So we set them equal to each other. So let's do our handy dandy calculator work. And let's divide all the big numbers together. So I got 18,976,457 divided by 15,982,378. 1.187. So it's going to be 1.187. Okay. So that's 1.0054 to the x. 1.0213 to the x. Okay. Now, what should we do? All right. So let's log both sides. So I'm going to get x times the log of 1.0213 equals the log of, remember we can break these up, 1.187 plus x times the log of 1.0054. Alright, so let's evaluate these logs real quick, see if that helps us. Alright, so let's do the log of 1.0213, and I get 0.00915. So 0.00915x equals, what's the log of 1.187336? 0.07457. 0.07457. And let's find the log of 1.0054. The log of 1.0054. 0.002338. 0.002238. 23388. 233 basically 9. All right. So now let's subtract those together. So I'm going to subtract 0.002339. So I'm going to subtract 0.00. So 0.00681. So 0.00681x equals 0.07457. So 0.07457 divided by my answer equals about 11 years. So x is about 11 years. All right, next section. Number 1. Write each expression as a single logarithm. 3 natural log of 5 would be the natural log of 5 cubed, which would be the natural log of 125. Number 2. Natural log of 9 plus the natural log of 2. You can say it's the natural log of 9 times 2, which would be the natural log of 18. 3. Natural log of 24 minus the natural log of 6 would be the natural log quotient property of 24 over 6, which is the natural log of 4. Next one. Number 4. 4 natural log of 8 plus natural log of 10. We can rewrite this as the natural log of 8 to the 4th times 10. Okay, 8 to the 4th would be 64 times 64. Alright, so it's 6940. So it would be the natural log of 40,960. Okay, number 5. Natural log of 3 minus 5 natural log of 3. So that would be the natural log, the positive number goes on top, 3, and the bottom number is 3 to the 5th. So we could actually rewrite that as the natural log of 1 over 3 to the 4th, which would be the natural log of 1 over 81. Okay, number 6. Could rewrite that as the natural log of 8 squared over 4 cubed. Be the natural log is 64 over 64, which would be the natural log of 1. Seven. 5 natural log of m minus 3 natural log of m. That's the natural log of m to the 5th over n cubed. Okay, number 14. Solve each equation, check your answer. Natural log of 3x equals 6. So what's the base of a natural log? It's e. So I could rewrite this as 3x equals e to the 6th. So x equals e to the 6th over 3. So e to the 6th divided by 3. 134.47. Okay, 15. The natural log of x equals negative 2. Well, the base is e, so it's going to be e to the negative 2 equals x. So that's just calculator work. E to the negative 2 0.13533. .13553 and 1.3533. Okay, number 16. The natural log of 4x minus 1 equals 36. Well, the base is e, so we could say 4x minus 1 equals e to the 36. Add 1 each side, so 4x equals e to the 36 plus 1. Divide it by 4, so it's going to be e to the 36 plus 1 all over 4. Okay, so clear everything. E to the 36, enter, plus 1, enter, divided by 4, enter. Alright, 1.07 times 10 to the 15th. 1.08, I guess, times 10 to the 15th. Alright, 17 if we can get it done. The natural log of 2m plus 3 equals 8. So we could say 2m plus 3 equals 8.